Is, yeah. So the 1 is in the square root. Now it says x plus 1, but we know that when we do plus, it actually means go to the
right
left.
Wait, when we do plus?
If it's inside,
Oh.
it goes to the left.
That's whack.
Now there's no number out here, so what does that mean?
It's on the
Oh,
it's
that
on
means
0.
that-
It doesn't go up or down.
It means it doesn't go up or down. So it means that the y coordinate, there's a vertical shift of nothing. Doesn't go up, doesn't go down. If there's a number, you'll see it outside the square root, kind of like this one, or like this one. So this one would be like going up 2. We don't have that. So what we're going to do is, using the h and the k, we have found one point. That point is important. It's kind of like the starting point. It tells you where the swooshy thing starts, okay? And then we'll know in general where it goes by looking at other things, but we know where it starts. It starts at -1 and then 0. The rest of it is either going to go up and to the right, down and to the right, up and to the left, down and to the left, based on a few other things. Okay. So the other things are like negative signs. We're looking for, is the x positive or negative?
Positive.
It is positive. Is the square root positive or negative?
Positive.
Positive. Now if it's positive, positive, it's gonna go, so positive x's go this way, positive y's go this way. So in general, don't draw this. It's gonna go this way. Don't draw the purple stuff, just draw the orange stuff. I mean, you can if you want, I guess, but that's not like part of the graph, is what I'm saying. Okay? So since the x is positive, that's gonna make it go to the right. And then since the square root is positive, that's what's making it go up. So in general, it's gonna curve something like this. And then we need more points. So we're gonna make a table. In our table, we already have -1, 0. We're gonna get 2 more points to graph the rest.
-2.
So the points you pick should be to the right of the starting point.
0, 1.
Okay, so let's try 0. Okay, so this is our function. We're gonna plug in 0. Okay, so this 0 plus 1 is 1, right? And the square root of 1 is 1. Okay, so that's good. So we plugged in 0. We got 1. Let's graph that point.
1, 2.
But it's not 1, 2.
No.
What? Do you know what the square root of 2 is?
25.
When you pick numbers, you want to pick numbers that will like be rational when we plug it all in.
Let's just go 3 because it'll be 4 and then it'll be 2.
There you go.
Oh, man.
So if we make x 3, this will be the square root of 4, and then it'll be 2. So that's a good choice. So 3 and 2.
Oh, thanks.
All right, so then what you're gonna do is you're gonna, so I made my starting point a different color on purpose. You're gonna connect your starting point to those black points, and it's not gonna go to the left, it's only gonna go to the right.
What?
So you only have one arrow. Don't put an arrow on the other side.
How would it go
Like this?
Huh?
How would it go to the other side?
It can't go to the other side because anything we plug in that's smaller than -1 is going to give us a negative number in here, and then we can't do it.
So like, how would you said like don't draw it to the other side? But how would you do that? With the points?
I don't know. People
Plug it in,
do.
don't
They
have-
go like this. They like go like
You
this.
just try it.
Or they go like this, and that's wrong. Like, you wanna
You
do
do
that.
numbers greater than 1.
It's just habit, I guess, is
Yeah,
what
big
it
dummy.
is. So this is our graph. Yeah. All right. Now with our graph, we're gonna state the domain and the range. The domain and the range describe the x's, the set of x values, and the set of y values. So the domain tells you what the x's are doing. Now, I said that the starting point was important. Okay, the starting point gives you part of the domain and part of the range. Okay, the -1 is the x coordinate, and the 0 is the y coordinate. So the -1 is going to give you part of the domain. It's either going to be x is bigger than that or x is smaller than that. Now, does x get greater than -1 or does it get smaller than -1? It's greater because it's going to the right and they're getting towards the positives. So you're going to write x is greater than or equal to -1. If x is anything smaller than -1, we'll get negative square roots, which we know are bad. They're imaginary. They don't exist on the coordinate plane. Now the y reacts to the x. Because the x is stuck, the y is kind of stuck with it. Okay? So because we can't plug anything less than this in, I'm not going to get anything down here, like I'm stuck. Also, if I graph stuff down here, it's not a function anymore. So the y is 0. It's either going to be y is greater than or equal to 0 or y is less than or equal to 0. So are our y's getting bigger than 0 or smaller than 0?
Our y's are gonna get bigger.
They get bigger. So your range is that y is greater than or equal to 0.
I have a question. So, when it says like greater than or equal to 0, right? Like, how would you? So like, can you just tell since it's the plus up top if it's for your range? You know what I'm saying? Since it's a negative or it's going in the negative direction.
Well, this is going in the positive direction.
Or,
I mean this one?
Yeah. Can't you tell or no?
So this part just tells us what the x coordinate of, like the smallest x coordinate is in this example. The part that tells us it's going to be greater than that is the fact that x is positive. If x is negative, we're looking at something like this, then it's going to be x is less than that.
Yeah.
So if x is positive, it's going to be greater. If x is negative, it's going to be less. Okay, questions? Any other questions before we do the next one? Okay, let's do the next one. So the next one, it looks really similar, but it's not the same. What's different?
The one is outside.
The one is outside. Now that changes the starting point.
It's 0, 0.
It's not 0, 0. This is 0. The x is 0 because it's not, doesn't have a horizontal translation. Okay, the +1 on the end, that is going to be a vertical translation
Why?
because it's the k.
Oh.
So the k on the outside after the square root, that's a vertical translation of up 1. So our starting point is at 0, 1.
Chill.
You doing okay?
Wait, did we, like, you know, in the last problem, we, like, went over, like, if it's, like, positive?
Yeah, we're going to do that.
Oh, okay, my bad.
Yeah.
Okay, so then how is the? I don't know.
So graph your starting point.
Yeah, so what would be our, okay, just 1?
0, 1. Because there's nothing with the x, so it's just up 1.
Okay.
Okay. Now I got you.
Trace.
Make your chart.
Wait, before the chart, we're going to get a general idea of what this looks like.
It's positive.
In general, we know which way this is going because of two things.
It's positive.
The x is positive, and then up here is positive.
Okay.
Okay, so we know in general that this is going to go somewhere this way. Then we're going to make a table to figure out exactly where those points are. So in our table, we already have 1 point, 0, 1.
Yeah. That means stuff greater than that, right?
Sure.
Yeah.
You need something greater than 1?
Yeah.
Greater than
0.
0. So 1.
So 1.
Try 1.
Alright, so try 1. What's the square root of 1?
1.
1.
2.
1 plus 1 is
2. Try 3.
4.
4. 2.
No, it's definitely not 4.
What's the square root of 3?
3. 3 plus 1 is 4.
That's not how that works.
What?
You have to square root it.
Oh, I'm not trying to do that.
9?
That's really big.
Try 2. 2.
What's the square root of 2?
Yo.
3.
No!
Bro!
Perfect squares, guys. What are perfect squares? 0, 1, 4, 9, 16. Those are the numbers you should be picking.
36.
4.
49.
The square root of 4 is 2.
2 plus 1.
And 2 plus 1 is
3.
3. Okay. Those are good points. Alright, so we have that little swoosh thing.
Switcheroo.
You can't just pick whatever points you want. You have to strategically pick points that are going to give us perfect squares. Otherwise, you're going to not have integers and your graph's not going to be accurate. Okay, and the square root of 3 is not 1.5. That's not how square roots work. It's not half of it. I wish it was, but it's not that simple. Let's talk about domain and range. So remember I said that these values here were important for the domain and range. So if the x is 0, we just need to know are our x's getting bigger than 0 or smaller than 0?
Bigger.
Bigger. So we're going to write y is greater than or equal to 0 here. And our y is 1. We need to know, are the y's getting bigger or smaller than 1?
Bigger.
Bigger. So we have a range of y is greater than or equal to 1. So it's going up in general. Slower up than it is going to the right, but it's still going up.
So,
Because there's a negative sign here.
So we know it's gonna go.
Okay.
That's negative. We know it's gonna go down.
Right. Now there's also, it's if it says plus 3, it's really like a disguised negative 3.
Yeah.
Okay, so your starting point is negative 3, 2, which is here. Now, because there's a negative sign in front of the radical, that means that it's going to go down. But the x is still positive, so it's still going to go to the right. So it's going to go down and to the right, something like this. So it's still going to the right, but it's now going to go down. And you'll know that anyway when you start plugging stuff in. You just want to make sure you plug the right things in. So if you have an x plus 3 here, okay, you want to plug something in for x that's going to make that a perfect square.
4.
You want it to be 4.
Right. 2.
You want what's in there to be 4.
Yeah.
Yeah, so,
So
one.
x 1.
So 1.
1, yeah.
Okay.
Wait, I have a question.
Yeah.
So you want it to be 4 because why?
Because we can take the square root of 4 and get a
Got it.
rational number.
Got it.
So 1 plus 3 is 4, which is good. The square root of 4 is 2. We had that negative sign there, it's still there.
It equals
So then this is going to be 0. So that's right there. Now there's a point in between those points that we could have done. What's another perfect square that's smaller than 4?
Perfect square, 2.
1.
1.
1. Okay, so what would we have to plug in order to make this 1?
Negative
2.
2.
Good, negative 2.
So that's going to be equals 1 plus 2 is 3.
No, but it's
Negative, you're right, so it'd be
So 1. So negative 2, 1. Okay, and look at there. Ooh. Okay, so there we go. So let's talk about domain and range.
okay. So basically, the domain is everything greater than or less than 0.
That doesn't make sense. It can't be greater than or less than something. Are the x's getting bigger than negative 3 or smaller than negative 3?
Smaller. No, big.
The x's.
Yeah.
Big.
Oh, they're getting bigger. They're going to the right.
Oh, it's just like.
So x
You
is
got
greater than or equal to negative 3. The y's
Is he less than
are getting smaller than what?
2?
2.
So it's everything that's less than or equal to 0.
Right. And again, these numbers come from the starting point. So if you know the starting point, you know like half of the domain or half of the range. And if you don't know the starting point, that's bad. and you know nothing. And that's bad.